I'll just do a small video on the accuracy of the AVO Mk2, how accurate it is. I've got it's a 6L6GC, no name. It's Chinese, of course. Now, I've tested this valve, tube, whatever you want to call it, on another digital tester that I have, and it's given me these results for a plate voltage of 250, screen voltage of 250 volts, and negative grid volts of minus 14. It's given me these results: 72 milliamps current draw and transconductance of 6, which is book value. It's the characteristics, the specifications for this particular valve, 6L6GC. That's what it falls under those parameters. So what I'm going to do now is test the valve on the AVO Mk2, and I'm going to test it under differing parameters. So we have 3 columns here for a 6L6GC, and these are the parameters that I tested the valve on the digital tester, and this is the result that it gave me. Okay, so what I'm going to do is I'm going to test the valve under these parameters on the AVO, then I'll test the valve under these parameters, and then I'll test the valve again under these parameters. Now these last parameters, that plate volts of 350, screen voltage of 250, and negative grid volts of minus 18, these are the parameters that the actual data book for the AVO gives us. You see, so you got 6L6, 6 volts for the heater filament, negative grid volts 18, 350 plate volts, 250 screen volts. These are the results. So these are exactly the same as this last column. So what I'll do is I'll start on this column under these parameters, and then we'll go on to the next ones. Okay, so we've got the valve heating up. I have already tested it for shorts, so we don't have to go through this process. And because we're just testing the current draw and the transconductance, we won't worry about this dial here, the quality test. So I've preset the machine. So we got filament of 6, negative grid volts of negative 14 milliamps. We got the multiplier on 10. Plate volts 250, screen volts 250, and we're ready to go. So it should be hot enough. That's what we get. We should be reading about 72. I think the valve is still heating up. we're getting 72. We got 14, 250, 250. We're closing after 72. Okay, so that's what we're supposed to get. So that aligns with the previous test I did on it on a digital tester that is. So we'll now try the transconductance. So we'll back off. And we're expecting 6. Increase the scale. Back off. We're about right there. So we're expecting 6. We're getting about 6.2. So that's settling down. 6.2. So that's pretty close to 6. Well, there you go. We'll call that 6. So that is in line with what we're supposed to get under this column. Transconductance of 6 and current of 72. So we'll tick that one. That one's okay. We'll move on to the next column, and the parameters are 300, 200, minus 12.5. So we'll take that back. So 300 plate voltage and 200 screen voltage, and we need minus 12.5. So this is going to be a bit hard to get because that's 12 there. So 12.5 would be about there, I guess. Close enough. We'll call it close enough. I mean, the tolerance in this dial is quite fine, and it's a mechanical dial, so we got to make some allowances here, but that's set correctly. Screen volts 200, anode 300, negative grid volts minus 12.5. So what we should get 48. What are we getting? That's spot on, 48 milliamp current draw. Okay, so that's very good. I will test the transconductance, so we'll back off. Increase the scale. Back off. Increase the scale. Yeah. And we're expecting 5.3. Let's see what we get. You got 5.8. 5.8. 5.2468. Now that's still within 5%. That's 5.7. So that's not too bad. We're supposed to get 5.3. It's a little bit off. 5.6, 5.7. So that's not too bad. That's still okay. So we'll give that a tick. And the next one is the parameters are 350, 250, and minus 18. So we'll take all that back. Minus 18, which should be about there, I'd say. And plate volts is 350. And the screen volts is 250. Right? And we should be reading 54 milliamps. So that's reading about 48, which is a little bit less. And that could be because it's very difficult to get this correct. Just a tiny fraction of movement. That's about right. We're getting 51, 52. The valve is still settling down. Reading about, say, let's call it 52. We're supposed to get 54, so that's not bad. And the transconductance is supposed to be 5.2. So we'll adjust for that. We'll test that. Down a bit. And we're supposed to read 5.2. And we're getting 5.6, which is still okay, within about 5% or so. So that's not too bad. So put a tick on that one. So overall, I'll just take all this back. Well, overall, I could confidently say that for a 70-year-old machine or thereabouts, the accuracy is actually very good, and I'm getting consistent results on it, so that's the main thing. Okay, that's it for now.